Good morning to all. Today we'll see line drawing algorithm. First algorithm for drawing the lines. We'll discuss today about DDA line drawing algorithm. So in this XY values of end pixels should be specified by the programmer to draw the line. Algorithm we have to figure out which intermediate pixels are in the line path to draw that line. Pixel xy values constrain to integer values, so it is important we cannot use floating point values for the xy coordinates. Pixel xy values constrain to the integer values for that purpose. Actual computed intermediate line values may be floats, but rounding of these values is required. Computed point, for example 10.48 and 20.51 rounded to 10 and 21. So line drawing algorithm, in that, as we can see, so this is the screen which is divided into grid, and first point is given like 3 2. Here the pixel is drawn, and another point is given 9 6, and in between we have to generate the line. So which intermediate pixels we can turn on, or we can highlight the intermediate pixels, because line is passing through number of pixels. So it is cutting in this row 2, these 2 pixels are cut. In the row 3, these 2 pixels are cut. And so likewise in the rows and columns, which pixels should be selected, that we have to decide. So which intermediate pixels should be highlighted, that we have to decide. Based on this, the algorithms are written. Using line drawing algorithm, slope intercept line equation is given as y is equal to mx plus b. Given two endpoints x0, y0 and x1, y1, how to compute m and b? M is nothing but slope of the line, and b is nothing but the intercept of that particular line where it cuts to the axis. M is equal to dy by dx. Dy is nothing but y1 minus y0, and dx is equal to x1 minus x0, and b is equal to y0 minus m into x0. So this is you can decide the value of intercept with the initial values of x0 and y0. So it is showing x0, y0, x1, y1. So dx is nothing but the distance, which is x1 minus x0. So this is the horizontal distance, and dy is the vertical distance. So in this line drawing algorithm, numerical example of finding slope m, ax, ay values are given 23, 41, and bx, by values are given 125, 96. So we can find out slope by minus ay. So this is difference between y coordinates, so that is dy. So it is equal to 96 minus 41, 55, and difference between x coordinate values, that is 102, and dividing dy by dx, it gives 0.5392. Now digital differential analyzer, that is DDA line drawing algorithm. In that let us see starting point at x0, y0, and constraint x, y increments to values in range 0, 1. So case first, x is incrementing faster, that is m is less than 1. So this case we can understand where case A, x increment faster, that means line is close to the horizontal or x axis, and in that case dx is greater than dy. So if we find out value of m, it comes to m is less than 1, because m is equal to dy by dx, and dx is greater than dy, so denominator is greater than numerator, so it will be less than 1. So in that case, step in x equal to 1 increment, so x value will be incremented by 1 and compute and round the relative y values. Now in the second case, y is incrementing faster, so dy is greater than dx, and in that case m is greater than 1. So in that case y should be incremented by 1 and relatively x values will be calculated and round to that x value will be done. So in that we can see, as slope m is equal to dy by dx, for m is less than 1, we are having increment in x values, that is you can call delta x is equal to 1. Put in above equation, so m is equal to dy is nothing but y2 minus y1 divided by 1, as dx is equal to 1, where dy is equal to y2 minus y1 and dx is equal to 1. So y2 is equal to slope plus y1. So with this equation we can find each of the new y coordinate, we can find out earlier y value plus in that slope value will be added. So in general form, yk plus 1 is equal to yk plus slope value of that line. So in this DDA line drawing algorithm case A, where dx is greater than dy, so increment in x value is unit increment, that is increment it by 1, and relative increment in the y values is calculated, that is yk plus 1 equal to yk plus m. So x is equal to x0, y is equal to y0, illuminate pixel x comma round y, and increment in x value is given as, next x value is calculated by x0 plus 1, and relative y value is incremented with y equal to y0 plus 1 into m, and illuminate pixel x comma round y. Again, now next value, which is earlier value is x, again increment x equal to x plus 1, next x coordinate will be calculated by adding 1 into the earlier x value, and relative y value will be calculated, y is equal to y plus 1 into m, illuminate pixel x round y. So it will be done until x is equal to x1, that is last value or last x coordinate of that particular line. In between these 2 points we have to draw the line. So in this way we can decide the x and y values for the intermediate pixels. This is for case number 1. Second case, in which dy is greater than dx, so line is close to the y-axis, as we can see line is close to the y-axis. So in that case, x equal to x0, y equal to y0, illuminate pixel round x comma y. So in this case, as dy is greater than dx, y is incremented by 1 and relative increment in x is calculated. So it is equal to x equal to x0 plus 1 into 1 divided by m. So it will give some floating point value, adding 1 into 1 divided by m into x0, that is x0 is integer value, but still it gives some floating point value, and we have to round that floating point value. So illuminate pixel round x, so it will round to the nearest integer value comma y. Again in the next stage, y is equal to y plus 1 and relative increment in x is calculated, illuminate again pixel round x comma y until y is equal to y1. So y1 is your end point of that particular second end point in which we have to draw the line. So altogether, DDA line drawing algorithm pseudocode is given, compute m, that is slope of the line. If m is less than 1, float y equal to y0 initial values, and for x equal to x0, x is less than or equal to x1, we have to continue up to the end point, x plus plus comma y is equal to y plus m, and set pixel here x comma round y. Else, so another case is m is greater than 1, so in that case dy is greater than dx, float x equal to x0, that is initial value, and int y equal to y0, y is less than or equal to y1, y plus plus, that is unit increment in y, and relative x value is calculated, that is x is equal to x plus x0 plus 1 divided by m, and set pixel around x comma y. So in this set pixel, we'll write current color into the pixel in column x and row y in the frame buffer. So we can highlight that particular pixel. Actually, see, this is the DDA line drawing algorithm pseudocode. So this is the how we can proceed for the DDA line drawing algorithm. Some of the drawbacks of DDA line drawing algorithm: DDA is the simplest line drawing algorithm, but it is not very efficient. As we have seen, round operation is used. A round operation is giving the nearest integer value of that particular floating point value. So in that case, error will be entered as 0.51 will be entered to 0.51 will be deducted, and nearest integer value will be taken for this. So next algorithm we can study for minimizing error into that is Bressenham's line drawing algorithm in the next part.